Hello YouTube, welcome back. It is the afternoon on Wednesday, June 8th. This is our last installment in Life After Calculus. We didn't get to do this one in class because it's not very sagey, so I'm just going to use my pen app on my smartboard through my tablet here. So 2016 BC6, here we go. The function f has a Taylor series about x equals 1 that converges to f of x for all x in the interval of convergence. It is known that f of 1 is 1 and f prime of 1 is a negative a half. And the nth derivative of f at x equals 1 is given by the nth derivative of f at 1 is negative 1 to the n times n minus 1 factorial over 2 to the n if n is greater than or equal to 2. Write the first four non-zero terms and the general term of the Taylor series for f about x equals 1. Alrighty, so let's do that. Yeah, oh, I'm on the wrong thing. There you go. Okay. Alrighty, so let's see how we do this. Alright, so this is going to be 6a. Alrighty, hang on. Why is it not cooperating? I'm sorry, I'm having a problem with my smartboard. It doesn't want to cooperate. Okay, there you go. So 6a says, alright, so what is f of x going to be? It's going to be f of 1, which is, alright, let's write it out. F of 1 plus f prime at 1. Whoops, oh, back up. F prime at 1 times x minus 1. Alrighty. Plus f double prime at 1 times x minus 1 squared over 2 factorial plus f triple prime at 1 times x minus 1 cubed over 3 factorial. There you go. And hopefully these are all non-zero derivatives, so we get 4 non-zero terms, or a third degree polynomial. Okay. Alrighty, so let's fill it in. Now, what do we got? We got f of 1 is 1, f of prime of 1 is negative a half. Alright, let's put that in. So we get f of 1, whoops, my tablet's a little laggy here, sorry. F of 1, okay, f of 1 is 1. F prime at 1 is negative a half. Okay, and now let's see, what's f double prime at 1? Let's see, if n is 2, f double prime of 1 is negative 1 to the 2 is positive 1. 2 minus 1 is 1, factorial is 1, over 2 to the 1 is 2, so it's, sorry, 2 to the 2 is 2, so that's a 1, that's a 1, that's a 4, it's 1/4, okay. So, let's do that. So we get plus 1/4. X minus 1 squared over 2 factorial, which is 2, plus, alright, what's f triple prime? Alright, so let's see, so f3 of 1 is negative 1 to the third, which is negative, okay, and then it's 3 minus 1 is 2, and 2 factorial is 2, over 2 cubed is 8, so 2 over 8 is a quarter again, but it's a negative in front, so negative 1/4, aha, good. So plus a negative 1/4 times, I'm getting used to my stylus here, sorry, hang on. times x minus 1 cubed over 3 factorial. Okay. Alright, so what's the general term? Well, let me see. Apparently that derivative, that nth derivative is only good for n is greater than 2, right? But what if I plug in 1? Do I get the negative 1/2? What if I do the first derivative? Let's see. Negative 1 to the 1 is negative 1. 1 minus 1 is 0. 0 factorial is 1. 2 to the 1 is 2. Negative 1/2. It does work for 1, for n equals 1, by the way. I guess I don't want you to worry about what 0 factorial is, right? But I don't think it works for the 0th derivative. In other words, the function value f of 1 is 1. If I do 0 here, yeah, what's a negative 1 factorial, right? So it's, all right, so let's write it this way. So for a general term, okay, isn't it going to be, let's see, the first term plus sigma as n goes from 1 to infinity of the rule that they gave us for f, the nth derivative, which is negative 1 to the n times n minus 1 factorial over 2 to the n times x minus 1 to the n over n factorial. That's what we're getting, right? So like say when n is 3, again, let's do it. Well, let's do for n equals, no, that works. These are the numbers that we got. Let me look at this. Did I copy this right? Yeah, that's right. Okay, so that's part A. Fine, done. Part B. The Taylor series for f about x equals 1 has a radius of convergence of 2. Find the interval of convergence, show the work that leads to your answer. So if it's a Taylor series centered at 1 with a radius of convergence of 2, it's good from negative 1 to 3, right? Let's see about that. All right, so this is going to be 6b. Okay, so 6b says basically that x minus 1 in absolute value is less than 2. The center of convergence is 1 and the radius of convergence is 2. So in other words, x minus 1 is between negative 2 and 2. So to get x alone, we're going to add 1 to everything. So we get a negative 1 is less than x is less than 3. So what we have to figure out is what happens at the endpoints, at x equals negative 1 and at x equals positive 1. Okay. And let's just use the general term for that. Let's see. So, all right, so what happens, what is f of negative 1? Where did my mouse go? There it is. What is f of negative 1? All right, so if we use a general term, f of negative 1 is going to be 1 plus, right? All right, 1 plus sigma of, let's see, negative 1 to the n times n minus 1 factorial over 2 to the n. Let's put it like this, 2 to the n. Okay. Times what? Well, if I plug in negative 1, I get negative 1 minus 1 to the n is negative 2 to the n. So I got a negative 2 to the n. Why is this erasing? I have an eraser here? Okay. N minus 1 factorial. Okay, whatever. Now it's going to be times 2 to the n negative 2 to the n over n factorial. Alrighty. There you go. Alright, so now let's simplify that. Isn't that 1 plus sigma? Now, what is 2 to the n into negative 2 to the n? Isn't that negative 1 to the n? And what is negative 1 to the n times negative 1 to the n? Isn't that 1 to the n, or 1? And, alright, so the 2 to the n into the negative 2 to the n is negative 1 to the n. And the negative 1 to the n times the negative 1 to the n is negative 1 to the 2n, but that's an even power, so it's positive 1. So all those coefficients become 1. Then n plus 1 factorial, why can't I get a factorial down here? Okay. Into n factorial is 1 over n, isn't it? Isn't that what's left? As n goes from 1 to infinity. I'm having a little trouble writing infinity there. And that's the harmonic, right? So, or that's a harmonic. Well, it is the harmonic. 1 plus a half plus a third plus a quarter. Yeah, this is the harmonic. So, divergent harmonic. So, x equals negative 1 is no good. All right, let's do the same thing for f of negative 3. All right, what's f of negative 3 going to be? It's going to be 1 plus sigma, as n goes from 1 to infinity. Why can't it draw 0? Of, let's see, now what is it now? It's going to be negative 1, it's still going to be the negative 1 to the n times n minus 1 factorial, okay, over 2 to the n, right? But now if I plug in 3, I got 3 minus 1 is 2, and 2 to the n is 2 to the n, over n factorial. And so now what happens? Well, the 2 to the n and the 2 to the n cancels, and I still have the negative 1 to the n. And the n plus 1 factorial into n factorial is just 1 over n, because it's like 4 factorial over 5 factorial is 1 over 5. Let's get that out of here. All right. So, isn't that just, let's see if we can squeeze that over here. Isn't that just 1 plus sigma, as n starts at 1 and goes to infinity, of negative 1 to the n over n, which is the alternating harmonic. So this is the convergent, wait, hang on. Over n. Whoops. Ay, this is really bugging me today. I gotta get a better pen app. My stupid smart notebook doesn't work. This is something else, by the way. Alright, so isn't that the alternating harmonic? Which converges. Whoa. Oh, a little buggy today, sorry. Gotta get used to this. So we're going to include the 3. Included 3. Or x is an element of negative 1 to 3, inclusive of negative 3, inclusive of the 3, not the negative 1, so it's a semi-open interval. Alrighty, good. Alright, so that's 6b. Right, okay, now 6c. All right, the Taylor series for f around about x equals 1 can be used to represent f of 1.2 as an alternating series. We use the first three non-zero terms of the alternating series to approximate f of 1.2. Alrighty. Let's see, let's get another page going on. Oh my goodness. Okay. Alright, so this is going to be okay. This is going to be 6C. There you go. So 6C is going to be, well, let's see. I want the first three non-zero terms. Let's see. So what would be, if you take a look at f of x here, right? What would it be? It would be f of 1.2. Well, x minus 1 would be 1.2 minus 1 is 0.2. So its power is a 0.2. So 0.2 squared, right? So it's 1 plus 1 minus a half of 0.2 plus an eighth of 0.2 squared. Sounds good. There you go. So let's do that. All right, so since f of x can be approximated by by 1 minus x minus 1 over 2 plus 1/4 of x minus 1 squared over 2, so x minus 1 squared over 8. So that would be a second degree Taylor polynomial approximation of that. F of 1.2, if x is 1.2, x minus 1 is 0.1. So you get 1 minus 0.2 over 2 plus 0.2 squared over 8. And this is BC6, no calculator, guys. So we approximate f of 1.2 as 1 minus 0.1. Let's see, 0.2 squared is 0.04. Divided by 4 is 0.01. Divided by 2 is 0.005. And so you get, let's see, 1 minus 0.1 is 0.9 plus 0.005 is 0. Whoops. Okay. 0.0, I did it again. It's 905, right? 905. There you go. My resolution is a little screwy here. I don't know why. Alrighty, and that's it. Okay, good. And part D. Show that the approximation found in part C is within 0.001 of the exact value. Okay, well, if you go back to our approximation, well, we have, they said it's an alternating series, right? And it is. It's a positive, it's a negative, it's a positive. This is negative over here. The first term we're leaving out is greater than the absolute value of the error by the alternating series test corollary, right? So that's the error term. Alrighty, so let's write that. Let's see here. Okay, so 6D. There you go. Well, it's 6D, isn't it? There you go. All right, so the absolute value of the error is going to be less than the absolute value of that third term, the first term we left out, negative 1/4 times x minus 1 to the third, but x is 1.2, so 0.1. Sorry, x minus 1 is 0.2 when you plug in 1.2. So 0.2 cubed over 3 factorial. Alrighty, and okay, and that is, well, let's see, 0.02 times 0.02 is 0.04. 0.04 times 0.02 is 0.008. Divided by 4 is 0.002. And 3 factorial is 6. So 0.002 divided by 3. Wait, hang on. 0.2 squared is 0.04. 0.04 times 0.2, so 0.2 cubed would be 0.008, right? Now divide that by the 4, and it's 0.002, and 002 divided by 002 divided by 3 factorial, which is 6. Well, 2/3 is 0.6 repeating, so don't you get 0.006 repeating? No, 002 divided by 6 is 0.006 repeating. Sorry. But the question was to show that the error is less than 1,000th, and that is definitely less than 1,000th. There you go, perfect, done. All right, so I hope that was helpful. That's our last installment for Life After Calculus BC 2016 BC6 Day 9. All right, so there you go. All right, bye-bye, YouTube.